everyone, and welcome to a new showcase video, where today we are showcasing quantum Sudoku, which in my opinion is a really fun example and also really cool to see how a Sudoku puzzle can be solved in a quantum environment using Dynex. I assume most of you who are watching are familiar with what Sudoku is, but for the ones who aren't, I will briefly explain what Sudoku is, how the puzzle is set up, which rules are involved, and how to come to a successful completion of the puzzle. So Sudoku is a logic-based numerical puzzle, which is usually found as a 9 by 9 grid, which is divided in 9 3 by 3 subgrids or boxes. The puzzle can also be found in a lot of different grid configurations, such as 4 by 4, 16 by 16, 25 by 25, you name it. So the puzzle itself, it starts with some cells who are pre-filled with digits, also known as clues. And these clues, they are designed to help the player to come to a successful completion of the puzzle. The difficulty of the Sudoku can vary based on the amount of clues provided and their position in the grid. So when we play a 9 by 9 grid, each row, each column, and every subgrid must contain all digits from 1 to 9. The numbers must be logically placed to solve the puzzle, and the digits must be unique in every row, every column, and every subgrid. So how do we solve the puzzle successfully? Well, the goal of Sudoku is to fill the entire grid with digits according to the rules we just discussed. Players must use logic and deduction of possibilities to complete the puzzle. And once the player has successfully filled all cells, that leads to solving the Sudoku puzzle. So, are you ready to play a game now? So Yeti has very kindly granted me access to his lab environment from which we will be running the code today. Yeti and Sam have been working extensively on this quantum Sudoku code, which we will be discussing in a second. But first we need to check if the Dynex SDK is properly installed here. We call pip install Dynex. And as you can see, all requirements are already satisfied, which means the SDK is properly installed. Then we proceed to our Python environment. We import Dynex. Then we check if the Dynex SDK works as it should, which it does. That's cool. We can then proceed to the actual quantum Sudoku puzzle. So first we are calling a few dependencies. Then we mention we are going to run the computation on Dynex mainnet. We are running a 9 by 9 Sudoku grid today, which is what n is 9 means. And then we are defining a Sudoku plot, which is basically a solvable puzzle, which we will be generating now. So this is the puzzle we are going to solve today. So this function here is related to how we are going to solve the Sudoku puzzle. As you can see, it initializes a couple of penalties or constraints to make sure the code base comes to a correct solution. We are running the job on mainnet today, as I said earlier, and this is the description we will be seeing in the marketplace. We are using 25,000 quantum circuits today. So let's run it. So as you can see here, we have job 10,984. And we are running a maximum of 3 attempts to find the correct solution to the puzzle. So our job has now completed. As you can see, we have found a valid solution, which we can also see in the marketplace. Our job took 1 minute and 30 seconds to compute, and it cost me about 2.3 Dynex coins. And that is how you solve a Sudoku puzzle in a quantum environment using Dynex. And that is all for today, guys. I hope you all enjoyed this showcase video. I am working on more, so keep an eye out on our socials for those. And I'll see you at the next one. Thanks for watching. Take care. Cheers.